Okay, guys, today we're continuing with our Intro to Algebra series, and we're going to start looking at logarithms. So let's start with the definition of logarithm. So if we take our general formula for powers that we went through in our last video, so a equals b to the power of c, to rewrite this with logs, we can say the following is true. C, which is the power term there, equals log of the base b, base there, of the value a. So if this is true, then this is true. And that is a very simple definition of logarithms, right? So if you ever need to rewrite, if you ever need to work out what the log form is, just remember this, okay? And just as an example, we've got 25 equals 5 squared. Well, remember the power term is on the left equals log of the base, which is 5, of the value 25. Okay, so if you wrote in the calculator log with the base 5 of 25, your calculator will return the value 2. And just to show you that that's true. Okay, let's look at some examples. So in order to calculate the value of x, let's just rewrite this in the power form. So we will know that 16 equals 2 to the power of x. Okay, and so x must be 4 because 2 to the power of 4 equals 16. Another example, let's work out the base now. So again, we'll rewrite this as 81 equals x to the power of 4. So x must be equal to 3. That's because 3 to the power of 4 equals 81. And lastly, well, again, let's just rewrite this. We'll have x equals 7, which is the base squared. So x equals 49. Okay, now let's move on to the rules of logarithms. As we've done with everything else, the rules are very important, especially when you need to simplify a logarithmic expression. So the first rule is log of xy equals log of x plus log of y. So can we actually prove this? Well, let's start off with some definitions of logs. So we'll say that x equals a to the power of b, b equals log with the base a of x, and y equals a to the power of c. So c equals log of a of y, log with the base a of y. Okay. So in order to prove this, well, let's try to work out what the value of xy is, right? Using the definitions we've created here. So x times y equals a to the b times a to the c, which equals a to the b plus c. And that is using our very generic rules of indices that we went through previously. So what we can say is xy equals a to the b plus c. Okay. Now, in order to now what we're going to do is we're going to rewrite this in our logarithmic forms, and we know, as we've shown here, right? We're just going to rearrange this to give us this, and in order to do that, we're going to say the power term here is on the left hand side, so b plus c, and that equals log of the base, which is a, of xy. Well, can we go any further? Well, note that we've got the definition of b and c here. Alright, so what we can say is log a xy equals b, which is this, log of base a x, plus c, which is log base a y. So we've just proven that that must be true. Next rule, so log with the base a x divided by z, x divided by y equals log with the base a x minus log with the base ay. Okay, so let's prove this. So we're going to start off with our definitions again. I'm going to do exactly the same thing. So x divided by y equals um, a to the b over b to the c equals a to the b minus c. Okay, just using our very definitions or rules of indices. Okay, and we're going to do exactly the same thing. So x divided by y equals a to the b minus c. And using the same idea as previously, we know that b minus c equals log of the base a x over y, or x divided by y. Okay, And then using our definitions of b and c, we'll just say log with the base a x divided by y equals log with the base a x minus, okay, that minus there, log with the base a y. All right, move on. So next rule, um, a log of a log with the base a x to the power of n is simply written as that power term multiplied by the log multiplied by this log term. Okay. Now let's try to prove this. So we'll start off with our definition again, and this time what we will do is x to the power of n, which is a to the power of b all to the power of n, which using our rules of indices we know is a to the bn. So let's just rewrite this x b to the n. Again, we're going to rewrite this in our logarithmic form. So we'll note that the power term here, bn on the left, and then our base is a, and this is x to the n. Okay. Well, again, we have our definition of b here, so we'll just note that x to the n equals n times log with the base a of x, just using the definition here. And so we've just proven that that must be true. That must be true. Okay, so those are our three basic rules of logarithms. What we're going to do is now derive some additional results, which are very important. So we'll start off with log with a base a1 equals 0. Well, in order to get that, let's just rewrite this in our exponential form. So we'll note that that equals, so 1 equals the base, which is a, and then to the power of a bit on that side. Okay, and we know that's true from our rules of indices. Okay, so no violations there, it holds true. Log with the base a equals 1. Well, again, let's just rewrite this in our exponential form. We'll note that a equals the base, which is a, of to the power of the bit here, which is 1. And we know that's true, so no rules violated there, which is great. And then let's have a look at log with the base a to the x equals x. Well, again, in order to prove this, what we'll say is, um, let's do let's look at our rule 3. Okay, remember that log with the base a x to the power of n equals n, so this power bit log of this bit. Okay, so let's come back to this. Okay, so we'll apply that rule here and note that log with the base a to the x equals x times with the log with the base a of a. And from our previous rule that we just showed, this here equals 1. And so it follows that log with the base a to the x equals x. Alright, so our next rule, a to the log with the base a x equals x. So it's quite crazy, right? You've got log a to the x equals x, and a log of a to the power of log with the base a x is x. Well, let's prove this just for completeness, and we'll note that. Well, let's take the log on both sides, or of this side. So we'll have log with the base a log to a x. Okay. And using rule 3, we know that the power term can be uh, can be taken out on this side of the log. So we've got log with the base a x, log base, or log with the base a, and this is again 1, right? So we can say very easily that log with the base a of a to the log x equals log with the base a x. Okay, and well, these two just cancel each other out, and you're left with a to the log a x equals x. All right, and then the final rule, we've got log with the base a b equals 1 over log with the base b a. So notice how the bases have flipped. And in order to prove this, well, let's say this one here, let's start off with this. We've got log with the base b a equals c. Okay, so let's rewrite this in our exponential form. We'll note that a equals b to the power of c. Okay, and so b equals the c root of a, or a to the power of 1 over c. These are just taking our standard rules of indices, okay? Right, so now that we've got that, what we can say is log, or let's just rewrite this, so b equals a to the 1 over c. So the log of b with the base a equals the log of a, a to the 1 over c, right? And this we can use rule 3 again to say 1 over c log a with the base a, okay? And we'll note that that equals 1. Very convenient that that is equal to 1. So we have this equation, log with the base a b equals 1 over c. Well, let's go back to the definition of c, which is right here, okay? So log with the base a b equals 1 over log with the base b a. Okay, so we've just proven this. And yeah, I think that will do it for this video. And the next one, I think we'll just do some examples. So hopefully that was clear. If it wasn't, just remember the rules and apply them into expressions. When I do more examples, you'll see how it sort of aligns. So thanks for watching, and I'll see you on the next one. Bye.